Hello there. Today we're learning about proofs in triangle angle relations. So your essential question is, how do I write proofs? Your learning intention: I'm learning to write proofs for triangle angle relations. So you've got two warm-up questions. Pause the video and see if you can do them on your own. Well, I do hope you tried. If you're looking at the first one, we know that the we know that it is your mid-segment because you've got these two that say these pieces are congruent and these pieces are congruent. The mid-segment is 1/2 the length of the base. So I can either divide this one in half or multiply this one by 2. I prefer to multiply. So 2 times 2x is going to be equal to x plus 9. Four x is equal to x plus 9. I'm going to subtract 3 from both sides. I'm going to subtract x from both sides. I've got 3x is equal to 9. Divide by 3, and x is equal to 3. Okay, this mid-segment is 2x. So this is 2x, which means 2 times 3, and that gives me 6. 3 plus 9 is 12. We don't know what units we're in, so we just simply put U for units. Hopefully you were able to do that. Okay, now finding the angles is a little bit more tricky. Why? Because we don't always remember we've got parallel lines. We don't always remember that corresponding angles are congruent. So as I look at this next picture, without any math at all, I know if this one's 54, this one has to be 54 degrees too. Their corresponding angles are congruent. So now I want to finish looking at the last angle in my triangle. So for this one here, I'm going to take 180 minus 180 degrees minus 54 degrees plus 37 degrees. Okay, now let's see. Using parentheses, I can do this all at once. Let's see. 180 minus parentheses 54 plus 37, close it off, and I end up with 89. So this one is 89 degrees. This one also will be 89 degrees. The last one I need is right here, C. If you remember the external angle theorem, then you could add 54 and 37 together and get the degree measure. If you do not remember it, you can take 180 minus 89. That is your linear pair. That will give me 91 degrees. And we found them all. So as you're looking at these, always remember all the different properties that you have. Even the ones we learned at the beginning of the year, and as we went through the unit over parallel lines cut by a transversal, those all come into play. They're all important, so when you forget one of the concepts, it makes it harder later on as we go through geometry. Okay, so we have been looking at the external angle theorem. So we're going to prove it because it's a really quick and easy proof. We talked somewhat about it last class period when we were looking at it, about how we've got 180 degrees when we've got the internal angles, and we've got 180 degrees when we're looking at these two angles because they're supplementary. So we always start with what we're given. Angle 4 is an exterior angle of triangle ABC. Okay, now this one says we're going to use the linear pairs theorem. What does a linear pair mean? A linear pair means that they are supplementary. So we know that angle 4 and angle 3 are a linear pair. Okay, so angle 4 and angle 3 are a linear pair. So what? What does that mean? Well, what do their measures add up to? 180 degrees. So the measure of angle 3 plus the measure of angle 4 is equal to 180 degrees. Why can I say that? That's your definition of linear, of supplemental angles. They make that line. If they're a linear pair, they make a line. That means they're supplementary. Okay, so we've used the fact that you've got an exterior angle. We've used the fact that that creates a linear pair. If they're a linear pair, they're supplementary. What is our triangle sum theorem? Well, the triangle sum theorem states that the measure of your interior angles adds up to 180 degrees. So we're using that next. The measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 equals 180 degrees. Okay. As I'm looking at these two statements, statement 3 and statement 4, what do you notice? What do you notice? You notice that they're both equal to 180 degrees. If they're equal to 180 degrees, then they're equal to, these two will be equal to each other. So the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 is equal to the measure of angle 3 plus the measure of angle 4. All I did was substitute. Property of equality. How do I go from here to here? Well, I've subtracted the measure angle 3 off. So that is my subtraction property of equality. Okay, now I'm going to let my readers know I'm done. I'm going to put that little infinity sign down there. And that tells my reader, got it proved. Now you need to read it. You could also put Q, E, D. Both of those are ways for you to tell your reader that you finished the proof. So if you're still questioning how it happens, read it, listen to the video again. It's pretty straightforward though. You start with your exterior angle over here. You know these are a linear pair. If they're a linear pair, then they're supplementary. Triangle sum theorem says that they add up to 180. These both add up to 180, so they're equal to each other. I subtract the measure of angle 3 off and I am done. Okay, the isosceles triangle theorem states that if you have two congruent sides, that their base angles are congruent. The angles across from them, their base angles are congruent. So how do we do this? Well, we're going to start off with a given. We're given segment AB is congruent to segment AC. If you didn't have two congruent sides, you couldn't prove it because it would not be an isosceles triangle. So if you notice, all we're given is this on the triangle. We're not given the fact we've got that altitude drawn. So we're going to draw segment AD so that it bisects the angles. And it's going to bisect angle A. Okay, now we can do that because we know each angle only has one bisector. So if it has a bisector, what does that mean? Well, a bisector splits the angle into two congruent pieces. So we know that angle BAD is congruent to angle CAD. Why? Well, that's your definition of angled bisector. Okay, so we've defined angle bisector. We know what that is. Okay, the next step is to state that segment AD is congruent to segment AD. What property is that? Well, that's our reflexive property. Okay, now we've started out with our two sides are congruent. We've said these two angles are congruent. And now we've said this other side is congruent. What triangle congruency have we gotten? Side, angle, side. So by side, angle, side, we know that triangle ABD is congruent to triangle ACD. And if I've gone to all that work to prove two congruent triangles, what comes next? We know that corresponding parts of congruent triangles are congruent. CP, CTC, and we're done. Any questions? You're given. Then we add that auxiliary line. Remember we talked about auxiliary lines? We define them as something we add to our proof to help us prove something. And then we use the definition of angle bisector, reflexive property, congruent triangles, and CP/CTC. So we want to prove that triangles that measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 is equal to 180 degrees. Okay. So if we're looking at this, what are we given? We're given triangle ABC. And what do we do next? We draw that auxiliary line. We draw a line through point B parallel to segment AC. So we have a segment. We've got parallel lines. Now what? Okay, if we have parallel lines, what do we know about certain angles? Well, we know that if we're looking at interior angles, which ones are congruent? If I'm looking at angle 3 and angle 5, what kind of angles are they? Same side or alternate? They're alternate interior angle. So by using that definition, we know that angle 1 is going to be congruent to angle 4, and angle 3 is going to be congruent to angle 5. And those are your alternate. Interior angle theorem. Alternate interior angles, your alternate interior angles are congruent. Okay, now, what else do we know? Remember, we're wanting that 180 degrees. So if I cover this up and just look at the top piece, those three angles create what? They create a straight line. So I know that the measure of angle 4 plus the measure of angle 2 plus the measure of angle 5 is equal to 180 degrees. Now, why can I say that? Well, remember the angle addition postulate? Postulate is what we don't have to prove. Okay, the other thing is you've got that straight angle. So that straight angle also means we've got that line. So, angle addition postulate. And straight angle, a definition of a straight angle. So we're using two different things at one time. Okay, now we've proven that angle 1 and angle 4 are congruent. We've proven that angle 3 and angle 5 are congruent. We've got angle 4 here, we've got angle 5 here. If they're congruent, that means we can substitute in. So, the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 is equal to 180 degrees. This substitution. We've proven it, and we can say the sum of the interior angles adds up to 180 degrees. Your triangle sum theorem. So, start off with your triangle. You draw that line parallel. You use alternate interior angles for stating angles are congruent. You use the straight angle and the angle addition postulate to state that the three angles on your parallel line add up to 180 degrees. Then you can substitute the ones that are congruent in, and you have your proof. So how do you know you're successful? You know you're successful when you can write proofs for triangle angle relations. These are just a few of the proofs that we do.